Welcome everybody to the latest webinar in the Engineers Ireland Southeast series of events. We started this format of events when the pandemic started. Normally we host live events where we do site visits, but the webinar series has been very successful for us. And today we've got another exciting webinar. So today we have Michael Flynn and Tom Dunne from the FLI group, and they're going to give a presentation on the innovative concrete solutions for precast solutions for infrastructure projects and other exciting projects that they're working on. So before I hand over to Michael and Tom, I just want to, when I have the chance, remind everyone that the Engineers Ireland Southeast Region AGM is on the 19th of May, and it's in the Whitford House Hotel in Wexford. So if you log on to the Engineers Ireland website, you'll see the registration details, and anyone from the Southeast is more than very welcome to attend the AGM. So that's the 19th of May. So without further ado then, I'd like to hand over to Michael and Tom. I'd like to thank them for coming on board with us today. And really looking forward to hearing what they have to say. So Michael, here you go.
Thanks, Christy. Appreciate that. Hello, everyone. Tom is our managing director of FLI Precast Solutions based in Carlow. Tom will make the presentation. I just want to give a general overview of the FLI group. Some of you may have heard of us. We were founded back in 1987 by myself. We're now a diversified environmental services and solutions company involved in water, wastewater, precast concrete engineering, brownfield land contamination, and mining and landfill engineering. We've been around for a long time, have a lot of experience. We work globally. The Precast Solutions Company has been part of the group since 2018, and most of the product there is exported, although we have recently built up quite a substantial opportunity and market in Ireland as well, and Tom will talk through that. So FLI dates from 87, which is a long time ago. Lots of things have happened in the world since then, and we've grown and adapted and diversified and changed as time has gone on. And we're very proud of the FLI Precast Solutions Company, the team. We have a very diverse engineering team there. And I'll hand over to Tom now as the MD to take it away.
Thanks, Michael. So I suppose the ethos here and the driver behind Precast Solutions and the solution is...
Sorry, Tom, just one moment. Just sorry for interrupting. For those that are not familiar with the webinar series, so there's a function at the bottom there for questions and answers. So what we do normally on these events is that we keep all the questions until the end. So if you have a question, by all means, pop them up in the Q&A section at the bottom of the screen as we're going along, and then we'll deal with them at the end then. So sorry, Tom, sorry for interrupting you there.
No, you're all right, you're okay. So as I was just saying, the ethos here is, and has been since the company was formed, and has been driven forward by the FLI group since they took over in 2018, is to take lumpy on-site issues where we try to manufacture, or we try to deliver in situ solutions on site, and we remove that from site and do it in a DFMA. So we design it for manufacture and assembly using modern methods of construction where at all possible, to bring these which would normally have been site operations, take them off site. It gives, in a lot of instances, particularly in the larger infrastructure projects, there's up to 50% savings in man hours on site, which, as we're all aware, that of anyone that's dealing with site operations, there's a shortage of labor, number one, but there's obviously health and safety risks, more importantly, that we are all trying to reduce on site. And by taking something off site into a factory environment, you have continuous productivity where you don't have issues with inclement weather, etc., and different factors that are forced upon us on site through no fault of our own. The work processes then can be simplified and controlled better in a factory situation to suit the labor that you have. So you can introduce automation to certain degrees to use a lesser qualified workforce, but get a higher end product out of it. The QA controls are obviously a lot easier to manage in a factory controlled environment than you do have on site. And one of the leading pharmaceutical companies that we deal with at the moment has a drive by 2025, but certainly by 2030, that all of their sites will become an assembly point, as opposed to a site where, or an area where there's an awful lot of operators trying to build things together. That they're pushing for assembly on site for the most part. Carbon is a big issue. We normally leave this slide to the very end, but we put it in at the start here. Here in FLI, Precast Solutions, we were probably one of the higher percentage users of GGBS, that certainly from Ecosem's perspective, where we're using up to 70% GGBS in our mixes. This is we've allowed to do this by we heat the water going into the concrete process to speed up the heat hydration. We heat up the molds, which allows us to use that increased volumes of GGBS. So you can see there on the screen, like in 2021, we have cut not almost, but exactly 1,421 tons of carbon from the concrete manufacturing that would have normally been in there had we not been using that level of GGBS. We're currently in the process of installing photovoltaic cells, and there's a biomass burner going in. So we're going to further drive that down over the course of 2022 also, because as we're all very, very aware, in all aspects of our lives, carbon is a big issue for the world in general. What we do here is driven by early contractor involvement as much as possible, particularly with the audience we have here in front of us at the moment, because it's you guys and all us as engineers that decide what way predominantly a structure is going to be designed and developed. And what we like to do is we're all, and myself included, we all sway towards the in situ option. And for the most part, now it is changing, to be fair, but we prefer get in early with the designers, optimize an offsite solution as early as possible in the process, and in conjunction with our own design team. We have 4 structural engineers here who design our products in the factory here for us. For a lot of, in particular, the utility companies in the UK, United Utilities, Southern Water, Thames, etc. We will design, manufacture, deliver and install the projects. So we will indemnify them projects. And it takes workload from the consultants as well, where we will design the projects if we get in early doors, and we will give you the calculations, etc. to go with it. But because we're designing, we're taking an in situ design, our design will be in situ as well. So in the event of it doesn't work commercially for the client, it can be flipped over and the detailing can be run just to suit an in situ option as well. It's not introducing anything that we're not familiar with in the in situ arena that we all work in day to day as well. The technology we use here, it's large offsite fabrication. Basically what we do is, and we'll see it in a couple of slides just coming up shortly, where we have large precast units which have projecting rebar out them to lap over on site. We stitch them, as is the terminology we put on it here. We stitch all of these precast units back together to form, with large reservoirs in particular, or circular structures, so that you are getting your continuous monolithic structure on site. The unique design manufacturing process that we have here allows installation up to 90% faster than traditional methods on site. So for example, we've seen a couple of slides later, big circular FSTs, PSTs, you're down to 3 operatives on site, a crane driver plus 2 operatives putting in a 35-40 diameter FST, the precast element of it, in about 3 days. You don't have any complex scaffolding, you don't have any complex steel fixing on site, but at the end of the process, you do have a monolithic concrete structure with which you're going to get your 120 year design life as specified in the works information or the the client specification. We also have, we have 3 software packages, which we robot for the finite element analysis. We then detail in Tekla and or CADS RC and Revit if the client requires. So we would take in the models from particular clients, whether it's the holding down boats, etc., from superstructures, or whether it's all the M&E pipework, etc., and we bring them into our model. So we locate the holding down boats and cast them in if there's a superstructure coming down on top of our tank, or for the most part, all of the pipe penetrations that are coming into particularly water sector work, that we'll have those cast into our units. So they'll be cast in a horizontal position here on site, which makes them, obviously the accuracy, as we touched on a while ago, is greatly increased. Just a flavor of some of the structures we do. What you can see on the screen here now is a lot of our data center work. We probably have 4 main areas of our 4 main clients here at the moment. We have the data center sector, the water and wastewater, the housing, and airports. So as we can see on the screen, there's a lot of products for the data center sector at the moment, where we, as Christy and Michael said, we export right across Europe at the moment, with a couple of key data center providers. We also carry out the mechanical and electrical fit out here on site and tested in Carlow, so that when units arrive on site, we're again eliminating as much as possible the confined space issues, which are a growing concern on site. So we're negating that risk. And that has been driven by, as we said a while ago, that ECI, or that area contractor involvement with our client in particular here, who wanted to take as much as possible offsite. So you can see in the bottom left-hand corner of the screen there, where you will have the uni struts, cable trays, earthing bosses, all will be fitted here in the factory. All those units will be hydrostatically tested as well. So when they arrive on site, they are fit for purpose, and there's no further self-healing, etc. required. That was the data center we done. The top left-hand picture shows they are actually 6 and 6 is 12-meter deep units that we, if there's any of the CIS guys on the call, it's the pier out in Holt that we extended with the guys there. So in conjunction with the consultants on this as well, we developed a solution to take all of the in situ works and underwater works to reduce it as much as practically possible. And you can see in the bottom left hand corner, those units are actually gone 12 meters down to a profile. We use universal column sections, I think they were, that we lasered in on the seabed to land all the precast units on. And in conjunction obviously with the divers, etc. on the project also. Some of the other pictures then that we see here, these were for reservoir extensions in the UK, where there were big man-made reservoirs that had to be heightened due to the higher flood levels. The middle picture on the screen, there was a project where there was an architectural finish on the units, and in conjunction with Reckley in Italy, and the architects on it, we 3D printed Reckley mats that we could actually replicate the old Victorian style wall units that were currently in place. Again, we come at the bottom right hand corner then were foundation bases for the oil and gas sector for National Grid in the UK. So we're shipping 70, 80 ton units for shutdowns, in particular power stations where they obviously wanted to eliminate or reduce as much as possible the shutdown period. So we'll manufacture the bases and arrange the craneage, drop them in on site. So the shutdown goes from potentially a couple of weeks by the time you'd excavated, tied the steel, poured, etc., to just a matter of a couple of hours, where you can just have your crane rig back in your truck and drop in your bases on site. So again, it just gives you a flavor. We're just taking what would predominantly have been on-site issues and taking them off-site, but still giving you the same level of quality. Again, we're back to the data center sectors again. Penetrations, as we touched on a moment ago, I think there's 120 penetrations in some of these chambers, all hydrostatically tested, ladder rooms, pulling irons, etc. that go into the units. It's a fully in situ solution that we just manufactured offsite. And in addition to that, it had to be manufactured in such a way that these could be shipped to all of the data centers around Europe in this particular case. We're currently looking at 2 data centers at the moment for them in Australia, where we actually have shipped water retaining structures to before. An array of products that we currently have there at the moment. So MV chambers, LVs, primaries, secondaries, electrical pits. Again, speeds up the operation on site. For example, in Dublin Airport, we had 2,500 electrical pits to drop in the ground. They had to be manufactured to a 3 mil tolerance height-wise, so that the paving machine could pass over them. So like any issue or problem on site, if we know about it early enough, we can certainly come up with a solution to manufacture something within the tolerances that the project or the client requires. That's the bottom picture there, which shows the precast electrical chambers going to site with the manhole lids cast in. Just some other unique bespoke products on the bottom right hand corner, and we do an awful lot of trench work for ESB, data center, etc. And we supply them with protection bars if there is comms cables, etc. in them, and also with lids from Fiberlight or some of these manufacturers. We take that scope on board, and we'll supply them with McGuard boats, etc., where there's security concerns on site to keep the trench cover actually secured in place. So we deal with McGuard in the US on those particular connections. The infrastructure work, as I said at the outset, if you look at the top pictures, the one on the right, where we have a 35 diameter FST going into position, you have 2 operatives on the ground and you have 1 crane driver, and they will install that tank in approximately 3 days. And as you can see in some of the other pictures, all the units stand side by side. It'll be clear in a moment, and then they're stitched together with wet concrete. So you're getting a full monolithic concrete structure when you're finished. The key driver here, especially on circular tanks, is the reduced man hours. The complexity is completely taken out of it from a site perspective. There's very simple formwork which can be done off an MEWP both inside and outside, and you have all repetitive shuttering work, but you only have a 500 millimeter stitch to stitch all the way around your tank, and it speeds up your operation. It's difficult to see, but in the middle of the top left-hand picture, we send a rotating bridge with the units. So when the guys are actually tying the rebar, setting up their levels for the sloped floors into the hoppers, that they have a continuous guide to work to all the time too. So we'll help the contractor with other items on site as well to speed up and take the stress and the quality issues away from them. This was a product we developed for the DAA in particular, where it was a security barrier. Again, they came looking for barriers to temporarily fence off the site to split landside from airside. There was and is obviously a specific safety regulation as regards international airports, and it was developed. You can't really see it on that screen, but there's rebates and all built into the unit so that the fence cannot be pulled out at the bottom. The fence, if you look at the bottom screen, there is holes left in it, so the fence posts drop down at whatever centers the fence supplier wants them, and they can be removed. The ends of it are splayed slightly. It's hard to see it there, so that they can snake around bends. We give them 90 degree, 45 degree units. Again, it's just to speed up and be flexible with a simple thing like fencing off the site, that this can be put up, taken down, and still give that level of security. A lot of bespoke structures we'll do here as well. So a lot of spillways, etc., predominantly in the UK, coming from natural reservoirs, 100-year design life. Very, very bespoke. Obviously, you have tapering units going the whole way from whatever 2 to 3 meters at the top, maybe down to only 300, 400, 500 millimeters at the base. That's a replica of the circular tanks. Installation, you'd probably see better here on the pictures now. So you can see the projecting rebar which comes out of the units. The rebar on the right hand side of the unit will be stepped 100 mil off the rebar on the left hand side of the unit, so that they actually overlap each other on site. And then there's a simple formwork which we'll see on a slide or two after. which goes on the inside and the outside of the unit, and we stitch the units together. The installation sequence will be, once the excavation is opened up, we'll simply pour like a 75mm footpath, about 1.1 or 1.2 meters wide, where we land the units on them. This just gives us something to line the level and plumb the unit. We'll then tie the floor, big in situ floor like normal. You can drop in an MEWP, run around with, as we said, repetitive shuttering on the inside, and stitch your whole tank together. So you have a very, very fast, simple process on site. On the top picture, if you look to slightly to the left of it, we do send the turning frames, which are designed, manufactured and tested here, so that it protects the toes as the units are being rotated into the vertical position. So we will look after all of the temporary works. And speaking of temporary works, all the units will go to site with temporary stability toes on them, which negates the need for any temporary propping, etc. on site. We do make units, water retaining structures running the whole way from approximately 0.6mm up to 12mm deep at the moment. And as we discussed a moment ago, 100-year design life, and you're Reg 21 compliant for materials in contact with potable water. Bewley Bank service reservoir in the UK. The reservoir included the integrated valve houses, sumps and dosing chambers. There was, by MMB, Mott MacDonald Bentley were our delivery partner on this, and their numbers were, there was a 70% reduction in working at height, predominantly driven by the speed at which they can put it up. And there was a 35% reduction in deliveries to site, because you're sending in an awful lot less deliveries with bigger loads on them. So we're sending 28, 30-ton trucks into site, as opposed to multiple load trucks with rebar, concrete, etc. Image in the bottom right-hand corner of the screen shows you have your rebar overlapped. Basically on site, then you have to tie 3 or 4 vertical bars which have bobs tied into the base steel, and then the units come to site with an MKK system built into them, so that you don't have bolts going through the stitches. They simply clip on to the precast itself, shutter inside, shutter outside, and stitch your units back together. This was a job in the north of England. Again, this was the project I mentioned a while ago, where we to replicate the old Victorian reservoir to increase the height. To be fair to our designers here as well, in conjunction with the guys in Tilbury Douglas, as they are now, we had to integrate and design the structure to be able, obviously we just surveyed the old reservoir below and ensure that it wasn't compromised by the additional heights that were put into it. So we do have that design capability here within the business. Another element of the business here are slot drains, ranging in size the whole way from 300 up to 600 diameter, with junction boxes, bends, miters, etc. There are other systems on the market such as Gatic, etc., which have proven they're probably slower on site. This is very, very fast compared to some of the other options, up to running the whole way from C250 up to F900 loading. These are actually images taken from the airport in Dublin. So these are all F900 loaded or capacity loaded units. Probably should say, while we're just looking at that picture, in the manufacturing process here, I mentioned at the start where we will heat the water. What that allows us also to do, we heat those molds as well. We can actually turn precast 3 times a day out of the same mold. So it speeds up and the turnover period. You're getting a lot better bang for buck out of your operating costs and your running costs and your light and your heating in your factory. So there's potentially 3 times the amount of precast coming out of the same floor area than you would have if you didn't introduce those mechanisms to speed up the production process. Stormcast, very, very big across the UK, certain amount here in Ireland as well, predominantly in the housing sector. It's branded as Stormcast across the UK at the moment. It was an award-winning system for many years over there. There are other systems as well creeping into the market, predominantly plastic around here. We've over 1,700 installations. This system actually runs in depths from 0.8 up to 3 meters. It goes 0.8, 1, 1.2, 1.5, 1.6, 2, 2.4, and 3 meter depths. And it's predominantly for the house builder for stormwater attenuation. Again, similar to our infrastructure product, projecting rebar, hydrophilic strip, stitched together, in situ floor, which we would predominantly design in as fiber reinforced if the GI and the ground conditions allow. If not, obviously we'll design with an in situ design. Why Stormcast? Predominantly because of its flexibility in plan area, but a lot of it is because the utility companies in the UK want to be able to inspect, clean, and be able to maintain their assets. So by putting in a system similar to this, you can actually get back into your tank at any stage down the line after. Plus, obviously they can be put in under car parks, etc., under roads. Depending on the loading requirements, we will design them out. Probably one of the failings maybe with some of the plastic systems, that they're not as adaptable to more of the higher loading conditions that are required. And there's certainly some of them are not, they're very difficult to clean and maintain after. Just some of the features of Stormcast: high overburden, heavy vehicle loadings. Obviously we design out the anti-flotation, 100-year design life, unlimited size configuration, depths, as we said, 0.6 up to 4 meters. Short manufacturing delivering times. We do run these products and store them on the shelf here, so they're a very fast turnaround. Designed to BS or EU standards. No temporary propping, low flow benching options as required. Integrated sumps and flow controls. Factory fitted hydrophilic, and obviously the design of the joints is to keep the crack width below 0.2, so you're going to get that autogeneous self-healing. In situ floor slabs, absorbs the variations of ground conditions, and setting out strips, as I said a while ago, ensures the accuracy for plumbing and lining the product. Back to reduce cost. You can get everything you need into one system. There's no expensive backfill. We're designed to be backfilled with the excavated material. Price certainly, DFMA, as we said a while ago, significant use of locally sourced material by the customer, and ability to place under load, minimizing land grab for better utilization of space. So they can go under green areas, under car parks, etc. The housing products that we do at the moment, there was an area in the market. Obviously there's a big housing problem in this country and probably the UK at the moment as well. There's a shortage of labour on site. The poor block layer gets a bad rap every single time over this. So we looked at the options in the market to eliminate as much as possible the labour on site. No disrespect to any block layers that are relations that might be on the call, but with a focus on eliminating that trade as well, and primarily to eliminate the amount of wet trades on site. So we've taken an ICF house, an insulated concrete formed house. We manufacture it in the factory in a controlled environment and send it to site in panels. So you can see the likes of that house in the bottom left hand corner of the screen, which is a complex enough house. Takes about 7 to 8 hours to get it completely up and finished, gables and all included. So we're currently on a project there up in Kildare, where the developer has asked us, they want to get a house weather tight in 5 working days. So we'll stand our wall units. Their roofing contractor, in conjunction with our guys, have the roofs pre-made on the ground. We'll drop them up on Wednesday, Thursday, they lat and felt it. Friday, Munster, whoever's fitting the windows turns up, fits the windows in the unit. So come the following Monday morning, the unit is watertight and ready to hand over to their M&E, their internal guys, to start fitting out. So again, we're taking what was an on-site problem, bringing it to the factory to manufacture a quality controlled product that can be delivered to site and erected with minimal enough people. The house will go up with about 2 to 3 guys, as I said, about 7 to 8 hours. The beauty of it also is, because we're detailing these in particular in Revit, we will issue the window schedule to whoever the window supplier is. We'll issue the roof trusses to the roof supplier at the same time as we're going to manufacture, so that everyone is arriving on site on a just-in-time basis, and there's no lags between certain trades and other trades having to pre-measure before they get onto site. There's probably a small video thing on the next one, which just shows that the units actually being dropped in. So as you can see, yeah, but it's LMWP, the scaffolding is up around the unit as normal, and the units are dropped on, bedded in, temporarily propped. We've designed out then the connections here in the factory as well. So there's continuity on the installation both inside and outside. And then there is a structural grout then that goes down, which does two things. It gives you continuity on your concrete, but it also locks all of the bolts together. That's it, folks. We've gone through that, I suppose, in about 30 minutes, but the bottom line is, if you have any queries or questions on any of the products, or indeed anything else that you have coming up, feel free to give us a call.